So we're going to start this video. Let's go to the next slide. So when you look at this equation, let's make sure that we understand the different parts. So remember, this negative that we first see represents the reflection across the x-axis. This number 3 means that there's going to be an amplitude of 3, and because that's larger than 1, it's going to be a vertical stretch. To see phase shift, we're going to set what's in the parentheses equal to 0 and solve. Therefore, we see that this graph is going to move to the left 2 units from the parent function. Now just notice, when you look at this new guy, which has been shifted to the left 2 units, you might say, well, it doesn't really look like it's been shifted to left 2 units. But you need to recognize that the parent function isn't seen on here, and you might have changed the scale of your x-axis. So just know that when you set what's in the parentheses or what's directly attached to cos or sine and set that to 0 and solve, that's going to give you your literal shift left or right. Now, in my opinion, the most important part of this whole process is finding the critical values. This is super, super important that you have nice ordered pairs. So how you do that, you are going again to set what is beside the cos or sine, or what's in the parentheses, equal to 0. So see right here, we set it equal to 0, and we solve for x. And we always set what is beside cos or sine, or what's in the parentheses, equal to 2 pi and solve. And when we did that, we got -2 and -1. That's super important. That is going to be the end and start of your little segment. You are then going to divide into 4 slivers. So first, find the center. You add and divide by 2. So -2 plus -1 divided by 2 gets you -3/2. Then to find this little sliver, you have to do some math off to the side. You add -2 plus -3/2 divided by 2, and you get -7/4. To find this sliver, you add -3/2 plus -1, and that's how you get -5/4. Once you get these 5 values, you're set. You put those values in the x column, and then you plug them into the function and do order of operations. So let's watch what happens when we plug in -2 for x. So let's find that. Over here, I plugged in -2 for x. So I plug it into the x spot, and you just do order of operations. So 2 pi times -2 is -4 pi, and add 4 pi, you get 0, parentheses first. Then evaluate, what's the cos of 0? Okay, well, look over here. The cos at 0 is 1. So then you have 1 times the number in front, -3, gets you -3 as an output. So here we have our first critical value. And if you look at the rest of these, I show you what happened when I plugged in, for example, -7/4, and so on and so forth. When you get those 5 critical values, it will give you a nice shape. So plot those points, and remember this cos, whether it's reflection or not, kind of has that bell-like curve. So kind of get the rough sketch. Remember, you can scale the x-axis however you like. So what I did is I just went along the x-axis, and I did those little increments based upon what I had on this little number line chart. Remember, domain is going to be all reals, because even though you just see a segment of that graph, you need to remember that it continues going on and on for all x values. However, the range, see how high and low it goes. Notice our graph, the lowest y value is -3, and the highest y value is 3. So let's quickly look at sine. So again, negative in front is going to be a reflection across the x-axis. Remember, if there was a negative right here in front of x, it would be a reflection across the y. So 1/2 means vertical shrink. Set what's inside parentheses equal to 0 and solve. we get pi over 2, so it went to the right, pi over 2 units. That's the phase shift. The number at the end is your literal up, down, up 3 units. So again, to graph, find the critical values. This is what is super important. Set what is beside sign, what's in the parentheses, equal to 0, and you set it equal to 2 pi. And when you solve, you get pi over 2, and you get 5 pi over 2. Those are your start and end points on your little number line. Then you just do simple math to find the halfway points. So 1 half pi plus 5 half pi's gets divided by 2 gets you 3 halves pi. Pi over 2 plus 3 pi over 2 cut in half divided by 2 is pi. 3 over 2 pi plus 5 pi over 2 divided by 2 gets you 2 pi. Once you have those little increments, you put those in the x column. You then do what we did before and you plug them in. So let's, for example, see what happens when we plug in pi over 2. When you plug in pi over 2 in the x slot, we have pi over 2 minus pi over 2 in parentheses is 0. You do the sign of that value first. So sign of 0 is 0. Multiply then next in order of operations gets you 0, and 0 plus 3 gets you 3. So that is our output. So one of our values is pi over 2, 3. Again, I show you the work when you insert different x values. So when you insert pi, when you insert 5 pi over 2, when you insert 2 pi. But those are the critical values. And if you do those, you'll get that nice shape. So remember, for the sign, we should have 3 dots that are all on kind of the same level. And then we have this U shape here, and then the U shape up here. Those are the 5 critical dots, because then they'll guide you. So remember, this is just one period. So when you're talking about domain and range, just remember it does continue on, right? So the domain is all reals, negative infinity to infinity, but the range is how high and low it goes. So the lowest value is 2.5, and the highest y value is 3.